Now we're going to analyze graphs of functions. You do this with respect to the x-axis, so I'm going to be scanning from left to right, like we did for our domain. For increasing, if you scan from left to right, and if your curve goes up, which means your y values are increasing, then that's what that particular function's doing at that time. In this next picture, as I scan left to right, notice your y values are decreasing. In this last one, notice my y values are constant. But you refer to this with the x's, so that's why you scan the x-axis. So for these two problems, we need to indicate where the curve is increasing, decreasing, or constant. So as I start scanning, my first curve is increasing from negative infinity to negative 2. So negative infinity to negative 2. You always use parentheses because a curve doesn't increase and decrease at the same time. The next part, from negative 2 to 0, I'm referring to the x's, my y values are constant. From 0 to 2, notice that my curve is going down or decreasing. And then from 2 to infinity, my curve increases. So I go back up here, use a union. And that's all I've got to do on that particular problem. My next one, as I scan from left to right, my curve is decreasing, decreasing, decreasing. So it's decreasing on the whole domain. Since it's not increasing or constant, I don't have to write anything down about that. So I'm just going to mark them out. Maybe go not applicable. For the next part, for us to analyze a graph of a function, we're going to look at determining relative min and maximum of a function. In order for this to happen, the curve is going to have to increase and then decrease, or increase and then decrease. For this to happen, a curve is going to have to increase and then decrease, or decrease and then increase. In this particular section here, around or near the x value of a, I've got myself a maximum. My maximum value is my y value. It occurs at that x value. Notice it's sort of like a mountaintop, a peak. I've got a valley here. Around this x value, I've got a relative minimum. My y value is going to be the smallest in this particular area. So I've got some examples on the next page. So we have to identify the location and value of any relative max or minima of the function. So the point is the lowest point in a small interval surrounding x equals, so the smallest point, notice this is where I've got a little valley here, so that's the point negative 2, negative 1, surrounding an x value of negative 2. So how we do actually say it is right here. At x equals negative 2, the function has a relative minimum of negative 1. Now the point is the highest point in a small interval. So here's a peak that occurs at the point 0, 1. So it's the highest point in a small interval surrounding x equals 0. But again, we refer to it like this. At x equals 0, the function has a relative maximum of 1. So, in this example, notice I do have a minimum here, a maximum, and a minimum. Maximums are always hilltops, minimums are always in the valley. So the first in the relative minimum, I'll just use my first one here. At x equals negative 1, I have a relative minimum of negative 2. The other relative minimum, at x equals 4, the function has a relative minimum of 0. For my maximum, it's at an x value of 2, and it has a y value that's a relative max of 3. One more. As you scan the domain of this function from negative infinity to infinity, notice that it increases the whole time. So does this function have a relative min or a relative max? Unless it changes direction, a min or a max will not occur. So no, and technically because this function increases on its whole domain. So that's it for analyzing graphs of functions. Thank you.